Hello everyone, this is Shumaila Sepi and my group number is 21 and my teammates are Vandana and Monica. So today we are here for our presentation. The topic is artificial intelligence and our main topic is roadmap research and development and machine learning agents. So we will start from agenda. So today's agenda is a roadmap of agent research and development. We will see what are agents and introduction. We will learn about autonomous agents, multi-agent system, applications and future directions, and then concluding remarks. So now we go to the slide, this one. So a roadmap of agent research and development. So what is it? It is a strategic plan. A roadmap, it is a strategic plan that defines a goal or desired outcome and includes the major steps or milestones needed to reach it. It is also served as a communication tool, a high-level document that helps articulate strategic thinking. It is the way behind both the goal and the plan for getting there. It aims to identify the key concepts and applications and to indicate how they relate to one another. So to understand the roadmap, first of all, we need to understand the agents. So what are agents? There is no any particular definition of agents, but yeah, in some loose words, we could say that agent research and that agents are, in technical terms, agents are programs that sense their environment, make decisions, how to act, how to react with the environment and execute the actions. And agents has, the actuators and sensors. So we can better understand the agents functioning by this figure. So we can see that agent has sensors and actuators. Sensors percepts the information from environment and then it give it to that information to actuators, and then actuators take actions and they get back the information to environment. So this is the way how agent works and how they cooperate with the environments. So now the introduction. So in introduction, we need to know about the autonomous agents and multi-agent systems. So this is the new way to analyze, design, and implementing the complex software system. So we will understand autonomous agents. What are autonomous agents? So coverage in autonomous agents and multi-agent systems includes, but not limited to, agent decision making, models, knowledge representations, and uh, you know any architectures and all. So what are autonomous agents? That are software programs which responds to states and events in their environment, and they work automatically. They don't need their they don't need their owner. They act in behalf of their owner, but uh, don't need their owner to command them. They are like independent. They work independently. So these are autonomous agents. So history of autonomous agents, where they come from. So autonomous agents come with the term artificial intelligence. When the artificial intelligence come, so the autonomous agents automatically come. So there are several different areas where this term came from: the artificial intelligence, object-oriented programming, and human-computer interface design. Now, issues and future directions. What can we get in future with the help of autonomous agents? So these are, these are going to become very important, and these are going to play very important role in the field of artificial intelligence, because it is concerned with the enabling autonomous agents to, various aspects like goals, plans, and decision makings. Because autonomous agents are those agents who take their decisions by own. They don't need any external command from the owner, or they don't need any external command. So, and the so in this way, it is going to be very effective, very useful, very important in the field of artificial intelligence. Now we come to the multi-agent system. So after autonomous agents, what are multi-agent system? As the name it indicates, that multi-agent system is consists of multiple agents. So the agents in multi-agent systems are independent, are not totally independent. They are interconnected, and they have the partial information, and they pass their information to each other. So in that way, they communicate with each other, and they complete the task and the program. We could better understand this multi-agent system with the help of this diagram. So there are multiple agents, and this is the environment. So each agent do its own task, and with the help of each other, and they coordinate with the environment. So now here it is, my presentation is complete. So I'll call my teammate Monica to continue this presentation. Monica, please.
Oh, can you change the slide?
Yeah.
Myself, Monica Madineni. I would like to continue from the history of multi-agent system. In 1980, a collection of AI research held the primary workshop to speak about the troubles. Here, from the actors and task allocation through the contract net protocol, we can better understand the multi-agent systems. In actors, one of the first models of multi-agent system problem solving was actors. Actors are proposed as universal primitives for simultaneous computation. The low particle size of actors also causes problems related to the actor compositions called organization. It contains new and extended features for the active model. In task allocation, the work of Davis and Smith has brought the well-known contract net protocol. This protocol allows agents to dynamically assume two roles, manager and contractor. This protocol allows for dynamic task assignment and allows agents to bid on it. It performs multiple tasks at the same time, providing natural load balancing. Here are some of the early applications like air traffic control, the distributed vehicle monitoring task, and blackboards where multi-agent system can be done. Next slide. Cooperative multi-agent interaction. Here, multiple agents are a group. Cooperative multi-agents are a group of agents created to work together. Agents can build specifically for their strengths in the scenario, while other agents cover their weakness. Here, this can be understood carefully by the four basic terms: functional accurate model, partial global planning, joint intentions framework, shared plan model. In functionally accurate model it is one of the method. Agents in this approach just require a portion of some information required to solve their challenges, whereas in partial global planning there is no precise distribution. To make a commitment, all team members need to establish themselves accordingly, mutual beliefs and obligations. Commitment locks in teams with all members. At the same time, we will enter into a joint commitment to team tasks. In the shared plan model, different mental attitude intending that the concept is defined via a set of axioms that guide a teammate to take the action. Next slide, please. Self-interested self-interested multi-agent interactions. The basic term we use here is negotiation. The concept of interaction between self-interesting agents is focused on negotiation. Negotiation is considered as a method of coordinating and dispute resolution. It is not the term agent, but it describes about the agents. Agent communicate and repeatedly exchange suggestions and counter proposals. We can examine the use of agents and the overall systems. Like if the agents have learned everything, the common utility of the system is near optimal. When the agent does not learn the agent's individual utilities, then the benefits of collaboration are very small. If one agent learns, the individual utility of increases the cost. Agents can negotiate and reach efficient agreements without delay. Next slide, please. Issues and future directions. Here we are going to face two major challenges. Firstly, to deal the problems finding agents in an open environment such as internet. Each agent announces its capabilities to the middle agent. Various agent types have been identified, such as Matchmaker and Elo found that the behavior of each type of middle agent has certain powers. And the another vital trouble is powerful allocation of confined assets to a couple of sellers. Economic approaches, especially market mechanisms, are becoming more and more attractive to the mass scholars because the underlying assets are readily available. Such an approach assumes that the agent is selfish utility maximizer. Mechanical design. It is in a selfish society of agents, it is desirable for the entire society to behave as a desired when each agent maximizes the utility of the area. The final problem with the self-serving system is that the agent. Next slide, please. Applications. Uh, Here we have a wide range of applications like industrial applications, entertainment applications, commercial applications, and medical applications. Field of applications exist today and new systems are being developed more and more. Of all the system in all these areas, this is beyond the scope of this task. An overview of the major system in these areas include industrial applications. In industrial applications, we have a manufacturing, process control, telecommunication, air traffic control, and transportation system. In manufacturing, for example, if there is a cell for milling machine, these work cells are grouped more flexibly, efficiently managed for the production process of these factories. Whereas in air traffic control, Lundberg and Lucas described the air created by sophisticated agents. In transportation system, it represents the station that requires or can provide transportation and where the customers gather. In entertainment applications, the agent has something obvious role in computer games, interactive theater, and related virtually related reality applications. We have games and interactive theater and cinema. Coming to games, Gran and Cliff used agent techniques to build a very successful creature game, a synthetic agent that allows users to interact in real time. In interactive theater and cinema, this allows the user to play a role similar to that played by real human actor. Next slide. In commercial applications, uh, systems that operate in relatively small niches are strongly directed to commercial applications, especially in the area of information management. Here we have information management. The lack of effective information management tools has led to what is colloquially known as the problem of information overloaded. In information gathering, we have information filtering and information gathering. A huge amount of information is present to us every day. Focus on the information you need in information filtering. In information gathering, we just have to gather the information from various aspects. And in business process management, getting relevant, consistent, and up-to-date information across a large organization. For this reason, organizations have attempted to develop different IT systems to assist the different aspects of business process management. Medical information is the important growth area of computer industry. In the health industry, there are new applications for computers every day, like patient monitoring and healthcare. First of all, surgical intensive care unit patient care model is essentially a team model, and the collection is a work with specialists from a variety of disciplines. In healthcare, a gadget is designed to combine the affected person control process, which then a care program got to be devised for treating the affected person. Next slide. Future directives. Not only do they provide solutions to the real world needs, they also show the agent-based systems are useful and powerful solution techniques. Autonomous problem solvers that interact in different ways to achieve individual goals. The goal of the system is a useful software engineering abstraction. We strongly believe that agent technology has a potential to break into mainstream of software engineering solutions and to build the basic infrastructure before the main push of the development effect agent. You can start development between agents. Next slide. I would like to conclude that areas such as distributed cloud computing, object-oriented system software development, and man-made of autonomous agents that interact for individuals. In both the design and implementation of individual autonomous agents, and in that way, find your way to commercial products and real software solutions. You can take advantage of the potential of agent-based systems. I'm done with my presentation, and Vandana is going to continue. Thank you.
Can we move to the next slide, please? Thank you, Monica. So now I'll be talking about the multi-agent learning for engineers. So in this paper, we are going to talk about a lot about the multi-agents and what is it all about. Can we move to the next slide, please? So mostly engineers, they work on creating systems that can meet a particular requirement or the specification given. But what do multi-agent learnings do? So here we are going to design a complicated system that multiple agents can work on to design the system. And they can assist in designing this as well. So some of the major benefits of this is we can develop a lot of controllers that can all work together and meet the conditions or the requirements given from the perspective of an engineer. Can we move to the next slide, please? Okay. So why multi-agent learning? Okay. So as we can see that a flawless distributed control system it doesn't exist. So creating a control system that has a lot of components and each of it interacts with one another, communicates with each other, and they need to have the data from external or internal sources, and even the environment plays a major role. So all these factors including, you cannot create a system that is perfect. So it is very likely that creating a perfect control system is impossible. So to overcome some of these challenges, we have the paper has presented with us with a method called game theory method. So here what happens is there's an overall system which has a collection of interconnected or interlinked components. And these components, each component, the decision making for each component is now very simple. So as a result, what happens is instead of having a whole system, which is perfect, we'll be having separate small components which together form a better system. Like we have a perfect simple components rather than having a perfect distributed control system. So this is done or achieved through a concept called Nash equilibrium. Can we move on to the next slide, please? Okay. So descriptive, predictive, or engineer. So now that we have the concept of multi-agents clear, we'll have to see where it can be used. So let's say how we can use it. So we are defining a game. So that is where we have the important aspects or factors that come in. So some of the aspects that we have are players and the space, the strategy space where it works, and the player's utility and the environment and type of the game that is used. So these are all the important factors used while while we are trying to define the game. So what are the type of games that we have? We have a one-shot, repeated game, and stochastic game. So in one shot, what happens is we are mostly focusing on winning the game rather than trying to working on the technique, since it's just one shot. But when we have the repeated game, we are working on repeatedly achieving the goal. So we are not again focusing on the technique. So we are only focusing on achieving the end goal by repeatedly doing the same process again and again to get a better result. But stochastic game is a place where it is which is actually the best game that can be chosen. But implementing this in a multi-agent learning system is difficult. Can we go to the next slide, please? Nash equilibrium, like I just talked, each multi-agent learning system is trying to achieve their equilibrium, or is trying to go and reach a point where it shows that they have components that are perfect. But there are some drawbacks in this. So when we say like the game has a predefined set of rules or specifications that is already set, Nash equilibrium cannot be applied to that particular game, because it just limits the range of the game. And there is also a concept of the complexity. So if at all the game's complexity is lower than that of the complexity of the Nash equilibrium chosen, then it's not going to be effective using this method to see which learning methodology is better. So if the complexity also plays a major role here. Can we go to the next slide, please? Yeah. So right now we are only focusing on achieving a set of equilibrium, but we also have to focus on the performance. So assessing the performance of the system is also a major component. And then we have the, since we are like, from the beginning, the engineers are mainly focused on achieving the equilibrium. They're designing their game or the system in that way that it achieves the equilibrium. So what happens is it's lowering the player's utility. So instead of mostly focusing on establishing equilibrium, we have to develop efficient algorithms or learning approaches. And then we have the concept of average performance criteria. So if at all there is a system that is in a steady state, we take the average of it and use that to measure the performance. But if at all, let's say there's a drawback to this as well, when let's take an example of the emergency, routing the calls in emergency. Since they don't have a huge team, and since worst case situations are considered and there are dangers, so this is crucial, and their performance is not measured in average. It's only measured in each person individual performance is measured. So we can't use that concept here. So that's why average performance criteria can only be used on steady state systems. Yeah. So also the information availability is limited. So let's say we can classify that into action based and payoff based. So when is it action based is when agent has access to other agents actions. So that is when the system is action based. When when the agent has access only to his or her own payoffs, then it is payoff based. What is an uncoupled learning. So uncoupled learning is when an agent doesn't have access to the utility functions of other agents. Then we have the online payoff based learning. So what happens is neither engineers nor the economic system has access to the functionality of the utility. So in this case, they are asked to pay a amount where they are they'll be provided access to the utility. So that is the concept in online payoff based learning. And then we have the community cost. So each agent has a particular set of access defined to him based on the domain he's working on. So if one agent need access to other agents' utility functions, then that agent can be shared. But to share that information, they'll have a particular cost or amount that they have to pay. So this is the cost functionality applied in this learning mechanism. And then we have, so since the adaptive mechanism for multi-agent learning is huge, what we'll do is in social media, like descriptive social media, where the system learns from the players, like how the players are working. So based on that, the system is learning from it. So here the real-time processing is not, the model doesn't have to process a lot of the information. But in engineered system, on the other hand, what happens is it's each agent is a program component. So a learning system has to be dynamic and can be adapted as needed. And then we have the concept of bounded rationality. As the name suggests, that we have a boundary or a limit set to the processing capability of an agent. So to set this, while setting these boundaries, it helps us which helps to set the learning dynamics for each agent. So to conclude this topic, so to maintain stability and the performance goals, despite of some of the disturbances that come in, this concept is called as robustness. So this has to be achieved. So some of the essential features to achieve robustness in an engineering system is performance should not be compromised even when there is very adverse conditions, when the system is subject to adverse conditions. And system must ensure that the performance of a set of specifications is not compromised. So we are given a requirement, we have to reach that. So just to reach equilibrium, we should, or just because there are some external conditions or that is disturbing, the system specification should not be compromised. And also it is critical to maintain robustness in a dynamic setup, even where there are unexpected disruptions. So these are some of the essential features for robustness in an engineered system. And since multi-agent learning, whatever we are using now are simple, we don't have to worry about the agent's domain knowledge. But as if at all we have agents that are good and in the domain that they're working, it will help improve the algorithm's efficiency. Also, while making sure that some of the system issues can be solved because they have the knowledge on the domain. So including domain knowledge as system engineering specification is crucial. So when providing domain knowledge, we have to take into account the level of the information required to accurately explain the model and interactions, so as well as the complexity of the description. This way, we'll have a better system if we have both robustness and domain knowledge. Yeah, so with this, we would like to conclude our presentation on artificial intelligence. Thank you.